Hi, my name is Guillermo Alonso Alvarez Milo, and this is the video explaining the methodology about evidence one of mathematical thinking. Okay, let's start with, I'm going to share my screen. Um, okay, I did this project, this evidence with my partner, Ana Karen Correa Sanchez. And first of all, the first question is to obtain a scatter plot of the data. So what we did is pretty easy. We went to Excel. Well, we just copied the data that the problem situation gives us, the year and the sales in billions of dollars. And what we did was basically uh, we just put the graph. There were a lot of okay, so just that's it, and we just copy and here insert data, then put this graph, and then here you have the scatter plot, so that's pretty easy to do. And then it says to use the preferred software to determine what type of function adjusts best to the presented data and test the data with a linear model and different non-linear models. So we put the linear, the polynomial, the moving average, the exponential, and the logarithmic, and the potential. It's pretty easy to do this here. You only click here in one of the data, and here we put agregar línea de tendencia, and here you can choose between this is linear, exponential, logarithmic, polynomial, potential, and moving average. So that's also pretty easy to do. Then argue which adjust bear with a valid mathematical parameter. So we think that we think, and it shows that the best graph for this is the exponential one. Here you can see that it almost connects with every dot. But something very important here is that we click here with the value of R, and it is important that this value is very, very close to 1. So here we have 0.9972. And if we check with the rest of the other graphs, we're going to see that there's no other closer than the exponential one. This one, the polynomial, is close to 1, but not as the exponential one. And the moving average doesn't even have the R graph, the value of R. Sorry. So yeah, that's it. And we think that it's better to predict the revenue, the value of the revenue in the future. And in order to make a prediction for the revenue in the year of 2035, as you know, as I said before, the best one is exponential, but the most realistic one that we think there is the linear function. So as you can see here, for example, in exponential, here is the end of 2020, and in the future we put 15 periods. Here you have that is more than 800 billion of dollars. So that's a lot. So it's not realistic at all. And in the other hand, you have the linear, that it's a little bit less than 4. It's 38 and something. So it's more realistic. and it adjusts better to what we are looking for. And well, this is the function. The function. Here you have this little square with where you can show the equation, and that's how we got that. Yes, this equation, y equals to all of this, and this is doing this operation is how we got the value of y in 2035. And here is our answer. Do you think that the value is obtained is realistic? We do think that is realistic because of Netflix growth. And well, just in case that there is well, if they continue to having this impact in the market, I think that, well, we think that it's pretty possible that they can reach this number in 2035. It is more realistic with the linear one than with the exponential one or polynomial one. Any other one, this is the linear is the most realistic one, since it is possible. But let's see how the things are with Netflix in 2035. But possible, it is possible. And yes. Is there a limit to the company's growth? And well, yes, we think that there's a limit. And we decided to go with the path that, well, not all people like streaming services, or there's people who doesn't have internet connection, and there's people who even can't afford one of these devices that are required, that the service requires in order to work. So even the government, there are some countries where the government doesn't allow them to use this kind of services, like, I don't know, North Korea, Cambodia, etc. So yeah, there's a limit, and well, yeah, that's it. And well, in order to have a more precise model, a more accurate one, it is important to, well, we think that to have a little bit more data, like the cost or the revenue, etc., in order to have a more accurate one. And so we can have the break-even points and the maximum and minimums, and that will help us to have a more precise model, like said here. And well, here is a little bit more of how the revenue function, how it works, and how to obtain them, how the profit is obtained by these functions, and well, how to get break-even points and how to get maximum points. So yeah, that will be it. It wasn't that hard, but was a little bit long to do. So yeah, that's it. And thank you for your attention.